This video is on enthalpy changes of reaction in solution. So this is really just like the last video about enthalpies of combustion, or just like the other problems with specific heat and everything. We're just adding into this a balanced equation to determine our limiting reactant for our moles. So I'm going to make a note of that. So like other problems, just with balanced equation to determine limiting reactant for your moles. Okay, so what I've written out here is your delta H for your solution, right? In your reaction is going to be that whole specific heat, right? Specific heat times change in temperature times mass, because this is going to give you that Q, right? This is all Q. And that's going to be the negative for your reaction. So they are going to be opposite signs when we're talking this to this, and the Q is how we find it. And remember, because it's a delta H, it's going to be that over your moles. And those moles are going to be what you get from your reaction. All right, so let's do an example problem. So it says when 50 centimeters cubed of 0.1 moles per decimeter silver nitrate. So I'm going to label these. Here's a volume. Here's a concentration for silver nitrate. And then another 50 centimeters cubed and 0.1, so they have the same concentration but of HCl. So another volume and concentration are mixed. So here are our reactants in a calorimeter, right? So these reactions either are endothermic or exothermic. So that's what we're going to figure out. But the temperature change of the mixture increases from 22.3 degrees Celsius to 23.1. So we've got an initial and a final temperature. So our temperature went up. That in this solution that we're making, we've got it's endothermic, positive. So you're going to find the delta H for the reaction. So here is what we're solving for in kilojoules per mole. So we've got units. Assuming the combined solution has a mass of 100 grams and the same specific heat of water. So here's our mass for our solution, specific heat of water, and we can find a change in temperature. So if I subtract these two, I'm going to get 0.81 degrees Celsius. All right, so let's write our reaction here. So I've got silver nitrate and HCl, and they're going to make silver chloride, which would be a solid, and nitric acid, which would be aqueous. I'm not writing all the states, but I just need a balanced reaction, which this is balanced. So our moles are equal. So if I look at like concentration is moles over volume. So if I solve for moles, which is what we need, it's going to be our concentration times our volume. So the moles of the silver nitrate are going to be our concentration, so 0.1, times our volume in decimeters cubed, so 0.05, which is going to equal 0.005. And if I go back to the correct sig digs, which should be 3, it's going to be 0.0 moles. And the HCl, 0.1 times, right, same numbers, 0.05, would also give me 0.00500 moles. So limiting reactant, both of them are getting used up because this is a 1-to-1 ratio. If in a 1-to-1 ratio, one of these was lower, that would be my limiting reactant, and that would be my moles that I would use. So now we can go about finding our heat of our solution. So Q for our solution is going to be the mass of our solution, which was, if we go back up, 100 grams. Our change in temperature, which was 0.81. And it says same specific heat as water because it's mostly water when we have an aqueous solution. So 4.18 joule per gram degrees Celsius. So our heat of our solution with 2 sig digs due to the temperature is 340 joules. All right, and then we can find our enthalpy of reaction. So it's going to be our negative heat of solution. Okay, so negative, and I'm going to write 0.34 kilojoules because it asked for the answer in kilojoules, right? And I'm going to divide it by my moles, which would be this. So 0.00500 moles. So my delta H of reaction is going to be negative 68 kilojoules per mole. So it's essentially the same problem as before. We're just adding in this reaction and solving for moles in a different way due to concentration, not due to grams.